We want to start talking about logarithms, defining logarithms, using logarithms, and working with logarithms. I don't know if I've said this to you already. My husband is an engineer, and he always says, whenever I tell him we're starting logarithms this week, he always says logarithms are difficult. And they are. We don't think naturally about logarithms. So they take even more practice. So if you've been getting by with 1 hour of math a day, you might need to start working at it 1.5 to 2 hours a day. So let's remember that the inverse function of an exponential function is a log function. So if you're not comfortable working with exponential functions, this isn't possible for you. You need to go back and make sure you're very comfortable with exponential functions, and then we can move ahead. We say that y equals log base a of x if and only if x equals a to the power of y. Do you notice what we did there? Last week, when we were talking about exponential functions, we had y equals a to the power of x. And now x and y have switched places so that we can have a log function. There are a couple of things to notice. They both have a base a. And remember the restrictions on a. A has to be greater than 0. A cannot equal 1. That's true for exponential functions. It's also true for log functions. I also want you to notice that the answer to a log is the exponent here. And x in a log we call the argument. One of the things that helps us start to understand logarithms is switching back and forth between exponential functions and log functions. So here we're starting with exponential form. Remember what I said, the bases are the same. Here my base is 2. So we can write log base 2. We also said the answer to a log is the exponent. Log base 2 of 8 equals 3. Think about that. You know that 2 cubed equals 8. Now we're saying log base 2 of 8 equals 3. This is asking us a question. When we're looking at logs, the question is 2 to what power equals 8? This first one is a really good example to memorize and to use whenever you get confused. Because when I look at the next question, 12 to the power of 4 equals m, the numbers, first of all, 12 the base, 12 to the power of 4 is just too big. I can't think about that easily. And so it doesn't even matter what m is. But I can use that first example to help me change it. The bases are the same. The base here is 12. So we have log base 12. The answer to a log is the exponent. Log base 12 of m. We should also write down how to say this because people often talk incorrectly to me in their verifying. Log base 12 of m equals 4. Why don't you try the next two? Write them in log form. So again, the bases are the same. And the answer to a log is the exponent. The bases are the same. The answer to a log is the exponent. But how many of you remembered what we said last week about log base e? We could also write this as the natural log of 9 equals b. So we took the log base e and wrote it as the natural log. That would be the better answer. That would be the correct answer here. Now in our next example, I see I have a coefficient on b cubed. We want to simplify that first. Always isolate your power. Now we can change it to log form. Log base b. The answer to a log is the exponent. This is log base b of 2. Try the next one. Okay, we have to isolate the power. That means we want 2 to the power of k on one side by itself. Why don't you do that? Now we can see we have 2 to the power of k equals 7 over 5. Now we can write it in log form. I would suggest that brackets here are a good idea. Again, our bases are the same, base 2, and the answer to a log is the exponent. In the next lecture, we'll look at changing logs to exponential form.